Welcome back to Advent of Code 2018. It's been, what, 2 months since I left this hanging? I've got, what, 6 problems left? To make matters worse, I think last time I was mid problem 20. I think I'm going to scrap whatever I did before and start again, because that'll give me a fresh mindset. Hello, Maro. Hello, DIJ. You're planning to do the 2023 one? That's good. Yeah, I mean, that's coming up soon. So I need to try and finish this one off. I've got enough time. But yeah, that will start on 1st of December. It's going to be a busy December. Nine days to finish 10 puzzles. Sort of. I mean, in lots of cases, part 2 is just an easy extension of part 1. At least that's been the case this month. Sometimes they are whole new puzzles, but yeah. Yeah, I got pretty stuck on this problem 20. Alright, well, let's approach this with a fresh eyes. Okay, so, problem 20. Uh, 9 days. Well, oh, yeah, that's right. It's just those 6 problems. But there's sort of, I thought you meant because they have part 1s and part 2s, so it's kind of double. But then this 25 is only part 1, so yeah. Okay. That's a low-flying plane. Markman, thanks for the raid. What were you doing? Were you doing any Wheel of Struggle by any chance? I still have to finish off that Sonic run. Maybe today. Not looking forward to it. Today I'm just coding because I was supposed to finish this coding thing off before the whole spooky October thing, and then I just got sidetracked. Playing a game called Small Saga that came out last week. Okay. Everybody hates Sonic. Well, almost everybody. I mean, I haven't played much Sonic, but I definitely feel that this Sonic CD game doesn't capture the idea of going fast. Well, at least every time I try to, I go straight into spikes or something. Okay, so what have we got here? Okay. Oh yeah, I remember this. I got stuck on this problem last time. I was trying to use regex. I don't think you should be using regex for this problem. The 3D games are probably better for going fast. I was thinking that, yeah, because you can actually see, you can actually see where you're going. I don't know if, yeah, I mean, I haven't played much Sonic, but playing this Sonic game, it's like I don't feel comfortable ever going fast because you can't see more than like 1 second ahead of you. So. Yeah, that sounds... Yeah, if I'm going to play another Sonic game, I think I'd rather do the 3D ones. Alright, let me just get a bit more coffee and then I'll start reading this. What are we up to? What are we coding? Basically, we're trying to solve these. There's this programming challenge site called Advent of Code. Every year in December, you have problems that open up on each day of December until Christmas Day. So it'll be coming up this December as well. But I'm just doing a past archived copy from 2018 because I've kind of gone back and finished off 15, 16, 17, doing 18 now. 20 and 22 I did live during the actual Decembers of those months. And 23 is coming up. So yeah, it's really fun, and it's very beginner friendly too, because, well, at least the first few problems are. It gets harder, but it's made to be a very approachable site, no matter what your level of coding experience is. It is quite mathematical though, so you kind of need some sort of mathematical aptitude or familiarity with, I don't know, things like sorting things into orders and putting things into lists and dictionaries and stuff, but and some stuff. I mean, you need to know some stuff about, like, maybe basic physics and stuff occasionally, or basic statistics. But what language do you use? I use Python. I think Python's really the fastest for these problems. And in some cases, Python massively speeds things up if you can do clever things with strings and using the the eval method in Python, the sneaky eval, which lets you kind of evaluate mathematical expressions without having to write your own meaning of, like, plus and minus and all that stuff. You just run eval and it just parses the mathematical equation and gives you the answer. Yeah, so 2018, we're on to day 20. I started this in September, but when Halloween came up, I started doing spooky games, and then I kind of left this hanging. Is the goal to have the most efficient code? The goal mostly is just to complete it. The top 100 people get entered into a leaderboard, but that's a very high bar, and I've never really. Also, it's not time zone friendly because it unlocks, at the same time for everyone. So for some people, that's going to be in the middle of the night. I don't really care about the leaderboard, but there is a leaderboard. Some people do. The thing is, unless you know some of the real competitive coding strats, you don't really stand a chance at the leaderboard. There's some really kind of obscure ways of coding that really speed things up, but I don't like doing it that way because it doesn't match how you'd write proper software. A lot of people copy lots of libraries and stuff ready to paste in when they need it because they enter all sorts of competitions like this. And some people use ChatGPT to solve it. That was last year's was actually the first year where that became an issue. You're allowed to. There's no rule against it. It's just people are actually reaching the top of the leaderboard simply by copying the entire problem, pasting it into ChatGPT, and immediately getting Python code that spits out the answer. There's nothing they can do about that. That's the the world we live in today. I mean, in a way, that's a good thing. That means ChatGPT is able to solve pretty tough problems, but they actually added a comment about AI. Where have they put this? Is this on the website? Ah, interesting. Starting this December, please don't use AI to get on the global leaderboard. Yeah, I mean, there's no way he can detect that because all you do is spit out the answer, the final answer, which is a number or whatever. So it's just honor system, I guess. There may be some people still doing it, but whatever. There's just no way to avoid this stuff. Yeah, the guy behind all this is Eric Wastel. He popped into my chat for one of my streams once. But it's a nice interface. It's a very friendly kind of site. Yeah, I think it's now basically my favorite competitive coding site. It's not very competitive though, but along with Coding Game, which is also coming up, I think, next month. If it takes you 1 minute to solve it, you used AI? No. There are people who can solve it in seconds. That's normal. I can show you leaderboards from previous years before ChatGPT was a thing. I've watched YouTube videos of people doing it live. You can see them typing. Let's have a look at some of these, like, I don't know, 19. Okay, so this one took just under 5 minutes. It depends on the problem. Some problem it'll literally take a few seconds because they're like, that's the this is just a simple case of, I don't know, breadth first search, and then they'll just paste in their BFS and quickly tune it to the problem, and then they're done. So yeah, it's entirely feasible that you can solve it in a minute, and it does happen all the time. People started this early. When they were kids, there's the International Maths Olympiad, which is this competition which is similar to the sorry, not Maths Olympiad, the ICO, International Computing Olympiad. Is that what it's called? So people have been doing these kinds of competitions since they were kids and just kept it up. Okay, so this problem. The area you are in is made up entirely of rooms and doors. So rooms are dots, walls are hashes, doors are lines. I don't think it will matter though. This is just for the sake of the diagram. Okay. Okay, most of this is just flavor. Okay, so he writes a description of directions, which means go west, go north, go east. And this is a regular expression, which means that little, the caret at the beginning means start, and the dollar symbol means end, and everything in between is just the directions you go. So he's saying, for example, go west, north, and east. So if you're starting there, then you would go west, north, east, and you would end up there. Okay, and the route he gives you will guarantee that you visit every room in existence. So there's no rooms that you're missing. If you actually follow his instructions completely, you'll visit every room. That's what they're saying here. So given this, you can actually figure out where all the rooms are. Like if you saw this WNE, then you could basically build this map. You could say, okay, we know there's a room west, we know there's a room north from there, we know there's a room east. Not only that, but more importantly, you know where the doors are. Because every time you go, say, from here to here, then you know there's a door between these places. Okay, so given a regular expression, we can build a map. I don't think we need to actually build this visual thing. It's going to be a bit of a mess, but... So yeah, that's the start, that's the end. North, south, east, west. Okay, but here's the tricky bit, the branch. So when you see a vertical line, that means you can pick either one. And if you were to try all parallel routes, they would all, the union of all of them would cover all rooms. So it's not, if I just pick east instead of west, that doesn't necessarily cover all rooms. But if I try both NEN and NWN, that would cover all rooms. That's the problem here. That's where things explode combinatorially. What the fuck happened to my stream? Stream's crashed. Is it? Is it? No, it hasn't. It did drop a few frames, but it's still fine. Alright, okay. So consider this regex here. So it begins with ENWWW. So no matter what route you follow, you start by going east, north, west, west, west. So that's fixed. All right. And then, see, this is where it gets confusing because you've got nested brackets. You can pick either NEEEE, NEEE, or SSE plus either EE or N. So there's actually 1, 2, 3 possibilities for this nested branch here. So this is what we know so far. That's really confusing diagram. Okay, so east, north, west, west, west. So you start here, you go east, north, west, west, west. So that's what we know the map looks like so far. And now we have to do this branching thing. So exactly 2 options, but then the second option is actually 2 options itself. So if you went in EEE, you would get this. You would expand to this row here. But if instead you did SSE, so SSEEE or SSEN, you would then end up with this, basically. That's covering all 3 possible branches. And then we know the room looks like that, basically. Because there are no other doors. We're guaranteed to have covered every door, so the rest will be walls. And you can have an empty option, which means it's either NEWS, WNSE, or need nothing. So that you just don't move and move on to the next letters. So empty option is also an option. So for example, that looks like this. So far I think it's understandable. It's just tricky to deal with programmatically. Once we've done that, we want to know what the furthest room is from us. Well, maybe it's not hard. I think the approach I took before was just got me stuck. I'll start from scratch this time. So you want to know which room has the kind of the longest, shortest path, or in other words, the room for which the shortest path to that room requires passing through the most doors. Okay, I mean, that's, once we've got a map of the place, that's easy enough. Once we know all the doors. And in that case, we want to know how many doors you actually pass through to get to it. Okay, but the puzzle input is actually very big. That is the puzzle input. That's one string. So there's a lot of branching. Yeah. So therein lies the difficulty. It's you can't use kind of like very brute forcey methods here. You have to be somewhat smart about it. I think what did I do last time? I think last time I kind of did something with actual regex. Probably you don't want to do that because regex is, for coding problems, it's not very fast. It's efficient when you're using it to find captures patterns, but it's not clever. It just uses the basic regex approach. For this, you need something a bit cleverer. Still semi-brute force this. Depends what you mean by semi-brute force. I don't know. In my head, there's either brute force or there's something faster. I don't know what semi-brute force is, but it's not that long. Well, no. What really matters is how many vertical lines there are. Though there are quite a few, though. But how many? The nested vertical lines are that's what matters, because each nested vertical line is basically doubling or tripling the essentially the size of that nest. But yeah, okay, let's try and code something then. Charm. All right, this is what I did before. Let's have a quick look at it and then scrap it. So that's the input there. So I did get all strings. So I tried to get all strings. That's probably the wrong approach, because the sum of the lengths of all strings is probably too much. You need to be smarter in that. And like, for example, that doesn't need to be counted every time, because clearly you only ever do that once. So yeah, we don't want to do this. In fact, let's not even look at this. It's probably going to lead me down a wrong path. All right, bye-bye. Let me zoom in a bit as well. Okay, so we get the regex as, and I say regex, but I'm not actually using any regex libraries here. So that's the string. Okay. So what are we gonna do? So one approach could be that we have a starting point which is like 0, 0, right? That's our starting coordinates. And every time we go east, south, west, north, you know, if we go east, then that will become 1, 0. If we go north, that'll become 1, 1 or whatever. So if we were to follow this, we would end up somewhere. I don't know. Let's say like, I don't know, 8 minus 6 or whatever. How do we deal with branches though? Once you get to the branches though, you can't just have one coordinate. You have to have multiple, don't you? So the moment we hit this branch, we'd have 2 parallel possibilities. I'd gamify it with a character following the path and objects being generated as he goes. Then he teleports back to the start after he's done with a branch. So the animation would take longer than the code anyway. Oh, you're suggesting using an actual game engine? Yeah, I mean, some people actually have done stuff like that for Advent of Code. For this case, I think... I mean, the fact that I couldn't print all strings, because that took too much time, that probably suggests that would also take too much time, but... So in this case, if I were to do that might end up somewhere. Let's say, I don't know, now we end up at 4 minus 3 or something, minus 2 or whatever. And this one here would not move at all because that's an empty thing. So now if we got here, we now have 2 possible places we could be. Is this sustainable? Maybe. But what are we actually doing here? So and then we were to follow this, we'd have to apply it to all tuples. We could just replace all pipes with all... No, it doesn't change nothing because... No, because, example, if I had... say this. I can't even find the... Oh, there it is. There are 3 places you could end up here, right? But here there are 2. Here you have to follow this or this, and you end up at 2 different places. Here, there's 3 places you could end up. The third being one where you stand still, but standing still is not an option here. But you asked for the furthest one. No. What? You asked for the furthest room. What do you mean? Furthest room out of all the entire possibilities of this one big string. But you can't isolate that to smaller branches because you don't know where you're going to end up in the big string. You can't make any assumptions in these smaller branches. Because it could be that the standing still actually leads you to the furthest room. If the rest of the string actually makes you go back the other way. So you don't know anything about what's coming up, so... And I mean, some of these branches can also open up new doors, which create shortcuts. So yeah, you can't rule anything out. You got to try everything. All right. So if I do what I'm suggesting here, does that just work? So what is the complexity? The complexity is that we have lots of these to deal with, and each of them have to be updated every time. So the question is, how many would we end up with? Well, basically every time we see a vertical line, we introduce like one more. No, because if it's nested, then I don't know how many vertical lines are there. But if it's nested, then so there's 1,036 vertical lines here. Wait, is that right? No, hang on. Yeah, that's right. 1,000 of them. So, but if it's nested, then for all we know, it could be in the hundreds of thousands. All right. Well, either way, this seems better than what I was doing before, because we're not trying to keep track of the entire strings. We're just keeping track of where we could be at each point. Is this enough, though? Do we need to keep track of all these points? Yes, because every single one of these points could lead to a new door that we haven't seen before. And we're keeping track of the doors in a separate data structure. Doors equals, let's say it's a set. And every time we say we go from 5, 6 to 5, 7, when we see that, we need to update doors to what exactly do we store indoors then? A pair where the left item is, so basically this, we put this into doors. But we need some order on that to make sure we don't have duplicates. We could figure that out. Is that audible on the mic? See, when I was using OBS noise removal, that would have been. But now I'm using NVIDIA Broadcast, so I think it's really smart. Do you even know what I'm talking about? Okay, so but yeah, there was a plane flying overhead, very close, really close. Like literally, you could actually probably just throw a rock up and hit it, because I'm pretty close to an airport right now. It only happens a few times per day, though. So I think this approach might work. I need to be careful that I need to handle branching correctly, though. So this, we need a stack. How do we do this? So the moment you open an open bracket, all right, maybe I was trying to think of a way to do this, looking at this character by character, but maybe that's not the right approach, because when you get to these nested ones, it's a bit unclear what you would actually do. maybe when we find an open bracket, we then want to find the corresponding closing bracket so that we know exactly where the tuple, where the options are. And then for each option, we apply that option to our current set of positions. That will get us a new set of positions. Now, what happens if there's another bracket within one of those options? Okay, so we need a recursive method, basically. We want to say we want something like this. We want fine get final positions given S, which is a set of starting positions, and given a section of regex that describes set of moves. That's what we want, right? And this might call itself. Alright, we can start. I think I can start coding this now. Alright, so doors is initially empty. Let's say start. Let's say, yeah, S is set of starting positions. Hello, spacekeybeats.com. Just doing some tricky coding, as always. How do I get started here? So for each right, start with an iterator. I equals 0. While I is less than length of the regex, we want to say char equals the next character, the regex. All right, so the easy case is if it's just a letter. All right, so if wait, we need a temp. Hang on. Okay, temp S equals kind of like a copy of S. I mean, we could do it this way. Doesn't matter. This is our current, or should we just say... Let's call it current. Current S. Alright, so if car is not equal to open brackets. Alright, so then it's just E, S, W, or N. So we just want E maps to 1, 0. West maps to -1, 0. North maps to 0, 1. South maps to 0, -1. So we want to create an empty list here where we're going to have the new positions. Okay, so for let's say for pause in, so for each current location we want to add either east, west, south, or north to this and put the new result in temp current S. So new pause equals, so it's going to be pause 0 plus directions 0, pause 1 plus directions 1. That's our new pause. Now there's a door though, so we need to update doors. Because every time we do this, this is proved to us that there's a door between these two locations. So doors dot add pause new pause, but also we need to add the other way around because doors doesn't know about order. So because these are two-way doors. Okay. And then finally, temp new pause. And then when we've done that, we just say we now just replace current with the temp. Increment I. Okay, that's the easier version. The easier branch. Now, what happens when we hit an open bracket? Alright, first I think we need to find where the corresponding closed bracket is and also all the vertical lines in that level of depth. So then we have a set of k different options to choose from. Some of them may have nested brackets in, it doesn't matter. And for each of those options, we then apply get final positions recursively to that option to get where the final options would be for that option. So that'll give us k new sets, right, for final positions. And then we just union all those together so to have one big mashup of final positions. That'll tell us all the possible positions we can now arrive at. It will be more positions than what we started with. And we'll be invoking doors. We'll be updating doors within each of those options, so we're not forgetting any doors. Will that just work? I think so. I don't think I'm missing anything. So doors will be updated. Final positions. The only thing we need to know by the end of this is where all the places we can end up, and what were all the exact doors found in between. Those are the two things we need to keep track of. Nothing else. And when we've done this, the only thing we care about is doors. Right. So I get rid of this stuff. If we know where... Okay, how do we find... Okay, we want to search until we find the corresponding closed brackets, right? But as we're going along, we want to keep track of all the vertical lines that correspond to this open bracket. Because some of those vertical lines might actually correspond to lower levels of depth, because there's like nested tuples. So we needed a depth tracker, which is 0. Every time we go one level of depth in, we no longer care about those vertical lines. It's only when we return to level 0 that means we're on the same level as this, if that makes any sense. So depth equals 0. J, let's say J equals I plus 1, the next character. While true, all right, let's have some variables here. Open para is, we'll just say open brag equals I. J equals open brag. This makes it more meaningful. While true, so if I hate when you use while true plus exit. Maybe, what else would I use? I can't condition in this while because it needs to check two things. Well, I can sort of, but it wouldn't be much better, to be honest. It still suffers from any similar risks, so I'll just stick to this. I mean, I can say while Is that common practice in Python? It's common practice in any language, not in proper software engineering. You never write while trues in software engineering, but it seems like it would cause a lot of infinite loops. Well, not if you write your breaking conditions correctly. But in mathematical programming, it's entirely normal because it's like you write your break conditions, and if you write your break conditions correctly, then it will break out in finite time. I mean, how else would you write it? You can do for character in. All right. I mean, sometimes there's no easy way of writing it iteratively, but actually, you have a point. In this case, I think there is. We can just say for j in for or j in this case we are going character by character, but in some cases you're not. Some cases you're kind of looping about, you know, like kind of like using, I don't know, like breadth first search type things, in which case, like when you write breadth first search or A-star algorithms, you do use a while loop normally. Anyway, for j in range, so we want to start from... No, because this is not much better because we don't know where the final bracket is. So I don't know what the end point of this range is. I mean, so I think better to just stick with the while loop. Well, no, okay, the for loop is still better. It's slightly better. Let's say... All right, so if so, we're going to the end of the string, but realistically, probably be breaking out before we get to the end of the string. Okay, so if regex is that and depth is 0, then close bracket equals j. So we found the closing bracket, and we also break out of this, so we're done. Elif, oops, regex should be that plane was closer. Regex I just create a Boolean variable and set it to false as the exit condition if there was no other way instead of using while true. Yeah, I mean, that is actually safer than what I'm doing, but it's... but it does suffer from the same problem that you might never actually set that Boolean. But yeah, it's slightly safer, but not much safer. But I mean, you're right that it feels bad. I would never, ever do this in a proper piece of software. You never want the risk that your program could infinitely loop. That's like the worst thing for the customer. Yeah. So we want branches. We want to keep track of the branches. So we want Okay, so that's a branch we found, and it's at the same level of depth. Otherwise, if we open up a new open bracket, then we've gone one level of depth. Otherwise, if we find a new So in theory, as long as the string is well constructed, this is a finite loop. Oh no, it is a finite loop because we're stopping at the end of the regex. So yeah, we've avoided the infinite loop problem, but it could just as easily break, except arguably maybe the infinite loop is better because this will actually spit out an answer. So we don't know we've gone wrong. We get an answer. But with the while true loop, it hangs indefinitely, and we see it hanging indefinitely, so we're like, oh, there's something wrong with that loop right there. But if it actually terminates and spits out an answer, we don't know anything's gone wrong until we actually enter the input into the website, and the website tells us our answer's wrong. So that's one argument in favor of the while loop. But yeah, we'll stick with this. Okay, so So it's like a fail fast method. All right, so by this point we'll know exactly where the close bracket is and the open bracket and all the individual pipes, right? Now what? For K So how many branches will we have? It'll be number of branches plus 1. So I need to turn down my AC. So branches plus 1. So first branch will start from. So what do we want? We want new iterators to tell us the beginning and end of these sub-regexes. Okay. Let's say if K is 0, the starting branch, that will actually start from after the open bracket. So let's say SI equals I don't use S, say whatever, TI, I can't think of a variable name. Alright, TI equals that, basically. EJ equals Should... Okay, we can make this easier to code. Let's say we add 2 points to this branches. So we put... No. Put... Yeah, no, just open brack in there. So we contain open brack, and then we add each pipe, and then we add close brack. So now it's containing all symbols, right? In fact, yeah, that's fine. Okay. Now for k in range. So what are the number of... So if there's one pipe, there'll be 3 points in here. So it'll be length of branches minus 1, basically. That's how many different subroutines we want to call here. So TI equals pretty convoluted problem. Yeah, it is. Yeah, that's why I got stuck the first time. I was doing a completely different approach though. I don't even know if this is... I mean, if anything will work, I feel like this will, because if this doesn't work, then I'm actually kind of stuck. But we'll see. So TI will be... So we start just after the first symbol, and we stop just before the next symbol. So that means that's the substring, regex ti to tj, not including the final character. Okay. What do we want to get? Basically, we want to create a new final position. So we want to create a new current S, don't we? Current S is that. So we want to collect together all the different possible positions. Okay, so we call get final positions. So the starting set is going to be current S. That's not going to be modified. The regex will be the same. It doesn't actually change. Well, what we should do is provide starts and end pointers. That way we don't have to make a new string each time for the regex, because that consumes a lot of time. So now we need to modify some things here. While I is less than... So I equals start. While other people solved it using obscure packages that solve it in a couple of lines. Where have you found that? Is that like the Reddit thread or something? So we use end here. So here we want to change this to be end. Now we use the same regex, but we use different starts and ends. That means we never modify the string, because you can actually go to exponential time just by producing all the different substrings as new sections of memory. Whereas here we're literally just passing two integers to the end starts and ends of the new string instead of recreating that. That makes a world of difference. I've seen cases where you completely fail a problem if you forget to do that. This will give us a new set of positions. So basically we want to do final pause, and we want to union with get final positions, right? So for each of these branches, we compute where you end up if you were to follow that branch, and that means might do this recursively any number of times. But when it finally resolves, we'll get a set of final positions. We union that into this set here, so we've now collected them all together. That might remove duplicates as well, because they don't matter. So final pos will now be holding the union. And basically, current S is that, right? Or now where we can now be, or any of those current S, but this should be a set, shouldn't it? We want okay. Let's say S is a set. So current S is S. Make sure I'm using set notation if I need to. So we never change in place. So this is a set. And then we add. Yeah, that's good because that removes duplicates. All right, so, and then current, yeah, okay, that's safe. All right, so now we've got our new positions. Anything else? Oh, we need to update I, where we're sitting. So I equals, so it'll be branches, the last, that would be the closed brackets, plus 1. So in this case, we just add 1 to move to the next symbol. In this case, we skip to the closed parentheses. And we've already evaluated everything in between, even the nested branches, if this is coded correctly. So after all this is done, while I is less than end, so eventually I will hit end. Past end. Well, end is not a character. End is 1 past the last character. So we are here. What we ended up with. A current S should now be. So we just return current S. That's it. ultimately, what do? We call get final positions. So S is just going to be 0, 0. Can I... Start set is just that one possible place. So we want final positions with the start set, regex, 0, length of regex. That's it. Alright, well, the chances this actually runs. Wow, that was quick. That's promising. Even if it's wrong, it's an indication that what we're doing won't take an absurd amount of time. Because I still expect we're probably delving into all the branches. Alright, so let's assume it's right. I mean, how do we check that we're actually covering all branches? We want to know that we're actually hitting the end, right? Let's say when we get to this bit, let's print I. Let's just see what these numbers are. 14083. Does this look right? Why are these all so close together? So I would normally be done when a subregex is dealt with. Something seems a bit weird about these numbers. So we're printing I every time, so it should have... So most subregexes are like several characters long. So why are lots of these one apart? I don't understand. Let's go further up. Okay, so towards the end of the string. That seems right, maybe. Oh, here they're closing off lots of... Oh, maybe that's right. I don't know. 1, 2, 4, 5, 6, 7, 8, 9... Something still doesn't seem right. Let's check that loop. While I is less than end. Are we feeding in lots of small... Let's try printing start end for each recursive call. Yeah, why is it like this? What? Why are we doing that? Oh no, that's for empty tuples. That makes sense. That's for empty branches. Yeah, okay. Now that's a big one. Alright, maybe it's fine. It just seems there's so many little ones. Is that really what the string looks like? It does actually. There are lots of one length strings. Not that many though. Okay, maybe I'm getting too worried about the data. Let's just trust it for now. Alright, next step. We now have what we really need is doors. So we've got a set of doors. How many doors? $19,998. Does that make sense? So how long is this string? It's like 14,000. So we're saying roughly it's like one door per character here. That does actually make sense. Every character sort of introduces a door, but then branches add a lot more doors. But then there's also a few duplicate doors, so they don't get counted. So yeah, I think that kind of balances out. This all sounds plausible. Right, now what do? We now need to find the... Starting from 0, 0, we need to find the furthest room. So we need to do a breadth first search. Yeah, because the breadth will really mean the shortest distance to a room. And it would be a very simple breadth first search, won't it? Because we don't need to keep track of much, just how many doors we've gone through. Let's try this then. So alright, so breadth first search. We say start equals 0, 0. Well, no. Q equals start while Q. See, this is one case where you do need a while loop. Can't really do it with a for loop because it's an unknown amount of time spent on breadth first search. Although it's not a while true loop. You are actually conditioning on their stuff. But it's easy for this to slip into infinity. Okay, so current... Hang on. Say dist equals... That's the distance map. So current equals q.pop. Just get the next thing out of the queue. No, we're doing breadth first search, so... Oh no, this is fine. This, if we do this... Yeah, this will work. Okay, so... We're doing not breadth first search, we're doing depth first search. Doesn't matter, we'll get to the longest part. Current equals q to pop. All right. For delta in, so we want to look in all directions. So 0, 1, 0, -1, 1, 0, -1, 0. Neighbor equals current 0 plus delta 0. Current. I can't believe we're still on part 1. Please give us a nice part 2. I think it will be, judging by the number of completions. Alright, so if neighbor in dist, that means we can skip this because we've already computed it before and it's already been put into the list. So all right, so first we need to check that there's a door. So if current neighbor looks like the puzzles add at 7 AM your time. What time zone are they on? I assume some American time zone. EST. So for me, it would be midnight. Midnight is acceptable. Because I can always just do 2-3 hours, and if I can't finish it, just carry on the next day. Right. I mean, will I actually do them when the problem releases, or just do them during the day, the next day? I don't know. We'll figure that out. I'm not going for the leaderboard anyway, but it might be nice to do it kind of at the same time as everyone's sort of doing it. That might actually be nice. All right, so if current neighbor not in doors, skip that one. So if it is indoors, that means this is a valid neighbor. So we want to say dist neighbor equals dist current plus 1, and then q dot put oh no, this is not correct. We do need to do breadth first, because we're not guaranteeing the shortest paths. Damn it. Okay, hang on. We need proper queue. Depth first search is just for exploring, but we don't guarantee we're on the shortest path. We could take a long path that comes in a loop that finds something next to us. There we go. Alright, so we want q.get. So now it's BFS. While not q.empty. So what is the final result? Basically the maximum of these distance values. Print max this dot values. Is that it? All 247? Could it be? I mean, there's so many places this could have gone wrong, but I think we're kind of on the right lines, so it's just a... largest number of doors you required to pass through to reach a room. Yeah, BFS is recording the shortest distances, so that seems... Yeah. Okay, nothing went wrong. Surprisingly, there were so many places that could have gone wrong, but I guess the fact that it didn't infinitely loop kind of... I think it's basically, it's either correct or it just crashes or infinitely loops. I don't think it's easy to get somewhere in between where you get wrong answers spat out. That's as I said before, that's actually one of the benefits of using infinite loops, potential infinite loops. You can debug using the finiteness of your other code running. It's a naughty way of coding, but it kind of works. Okay. Yeah. So really, the problem that I faced last time was I was just trying to record all strings, and you know, if I didn't have this start-end pointer thing, I was just... So if I didn't use that, instead I would be... I mean, I can try this now. So let's remove that. I can undo all these changes. So while I is less than length regex, I equals 0, right? So this is just using the regex. We would go to length of regex. And then here, we would slice the regex. This creates a new string of that length. So we're building up lots and lots of strings. It might still work, actually. They might have been generous with the numbers here. It's not that big, but... And here we don't need these things. So now we're just creating lots of strings of redundant characters mostly. Right, try running it now. It still runs fine. But yeah, I mean, that can be a huge time save if these strings, if they're overlapping. These are non-overlapping strings, actually. So yeah, it wasn't a big deal because... No, they are overlapping. They are overlapping because you have a string describing a bunch of nests, and then you have separate strings for each of those nests. I think it's just, there's just not much nesting. They could have done more nesting, but they didn't. So, we're fine. Let's undo those changes though. Alright, but we're not done yet. Alright. Part 2. Okay, so the facility is big. How many rooms have a shortest path from your current location that pass through at least 1,000 doors? Well, we've got the answer in our in our distance table from the BFS, don't we? I don't see this being hard because no matter how people have answered part 1, surely they'll have the building blocks already there in place to get this quickly. Like, what could you have done? Alright, let's just do it first and then... So... It's a very generous part 2. So we want to... Oh. So we want to count how many things in this dist table are... So basically print sum of v greater or equal to 1000 for v in dist.values. So it's summing up the Boolean ones or zeros for that truth or false statement there. That's just the clean way of writing that. 8356. Right. Yeah, I mean, I think I already knew that it was going to be an easy part 2 because the leaderboard, basically everyone who solved part 1 solved part 2 as well. I mean, what could you have? What weird way could you have done part 1 where you wouldn't solve part 2? If you weren't recording the doors, but somehow found the shortest path to the longest room while you're parsing that big string. I don't think you can though, because you could this big long string could come around in a loop. So you do need to be keeping track of all the doors to finally compute the shortest paths to all the rooms. So I mean, at the end, you have to do some sort of BFS, right? I don't see how you can get around doing that. And if you do that, then the answer's laid out right in front of you. Yeah. I mean, yeah, the leaderboard tells us everyone who solved part 1 basically solved 2. Solved part 2. Wait, stats is what we want. No. Here we are. Yeah, okay. So there were 166 people who didn't solve part 2. Maybe they just didn't feel like it or something, I don't know. or they just genuinely got stuck. But that's quite a low number. The other case was 17. Which problem was this? Oh, the clay one. Yeah, I guess that was easy because you'd already done all the hard work in the first part. But, yeah. So, yeah. Okay, good. Got 20 knocked off the list, so 21. Quick preview. I'm not going to read it. Don't have any diagrams or anything, right? Oh no. Is this using... Is it? No, it's not using the assembly code, is it? Oh, it is. Damn. I forgot all that stuff, but we've still got the code for that stuff, so... Oh dear, it's a halting problem. The unsolvable problem in computer science. Alright, that'll be fun. What were the stats for that? Similar to this one. So, easy part 2 apparently, so... That's fine. Alright, well yeah, we've got just over a week left to finish this off in time for Christmas. It's going to be a busy Christmas, working hard every day to solve these problems. No time to visit family or friends. We've got to do Advent of Code, as we do every year, every Christmas. Will I even have time to stream Christmas games? Are there any Christmas games? I can't even think of any Christmas games. Die Hard. I've never actually played the PC game of Die Hard. Maybe I should. Actually, it looks alright. I think I played a demo of it a long time ago. Oh, I played one Christmas game a couple of years ago. It was Batman Arkham Origins. That's actually set on Christmas. I didn't play it at Christmas though. almost there. But yeah, Amara, if you're going to take part in this, you can also join this leaderboard. This is my streams leaderboard, basically for viewers, and then you'll appear here. How do I get the code again? I forget. Oh, it's here. You could just go to this page here, leaderboard, and then you type in this code that I'm pasting into chat right now. And then you'll be on that leaderboard. You can join various leaderboards. You can create your own if you want to as well. Oh, you're on it now? Let's have a look. Have you done any problems in any years? Is there a way I can get this for every year? No, it seems we have to go year by year. Yeah, I guess you won't. You may, yeah. Unless you're really enthusiastic, I don't think you have enough time to complete a whole month in time as practice. But you could try a few problems. I don't know. Up to you, really. You could just go in blind. The one thing I didn't check was what was the times for that problem. 20. 17 minutes 39. I mean, that's sort of on the high end. But yeah. Yeah, it's nice. This site is becoming the new thing. The popular sites of the old days used to be Topcoder. That's dead. I mean, it's still technically going, but only the really hardcore enthusiasts are still on that site. It used to be king. Well, that's the problem. All these websites which start out as competitive coding sites, they then turn into this, just like commercial products sites, and they hide the actual competition buried in the website somewhere. I don't even know how to see. It doesn't even mention the coding challenge anymore. Topcoder used to be a competitive coding site. No, there it is. Compete, buried in the site right there. Where do I go from here? Single round matches. Alright, it looks like it's still going, but it's... I don't know, they've buried it so much, they just don't care anymore. They just care about... I get it. They want to go where the money is, and that's enterprise level software and website products. And then there was Hashcode. No, not Hashcode. What was it called? HackerRank. That's also dead. Well, that's becoming an interview site. I think they've hidden away their competitions as well. See, they don't even have a menu for it. Have they actually deleted it altogether? No, I think it's still, I don't know, somewhere buried in this site they've got their thing. This used to be, after Topcoder, this used to be king, now that's gone. Google CodeJam has shut down, basically, as of this year. Because Google have basically fired all their employees, they're just having AI run everything. But I don't think AI is smart enough to write competitive coding challenges. That was also basically one of the best competitions. That's gone. It's all dying. Like the interest is no longer there. The competitive coding scene, but that was the last one there, August. But this didn't die because of lack of interest. This just died because Google just fired all their people. My old manager at Amazon actually made the scoreboard for this site, I think. It's a shame. You don't need that many people to keep this competition running, do you? You've got all the infrastructure there. You just... I don't know. I think the team that worked on it has basically been discarded. So yeah, of course there is one site that's still up and running, but this is not made by a major company. This is a bit more of an indie level site, so they care about this stuff. This is really the best site now for this stuff, and there's a competition coming up soon, so I'll be doing that. All right, it's enough thinking. I should. I've still got time before dinner. Maybe I should actually switch to Sonic. See, after doing some hard coding, I just want to play some stupid shooting game and shoot some enemies, not have to think about stuff. But maybe, yeah, I mean, Sonic needs to be complete. We need to get that done with. So I think I'll set up the stream for Sonic. I might do that in 5-10 minutes. All right, well, thanks for watching, Amaro. I was a bit worried because I thought I might get stuck on that problem again and not get past it, but I did. So there is hope. Did you hear that one? Planes are getting louder. They're flying closer and closer to my house. That didn't spike on the mic, so I think NVIDIA Broadcast is actually really good. It actually detects keyboard noises, it detects planes, it detects dogs barking, and it knows how to filter them all out. So if you have a powerful graphics card, I recommend NVIDIA Broadcast for your mic filtering. But on my last laptop, I tried it, and it just absolutely throttled my CPU. So you need you need good CPU and GPU. Advent Children. Hello, Zen. We need to translate off that written LED board. I'm sorry, what? Japanese word on the screen. Oh, where was that? Okay. This is just the copyright-free chill music that I normally play during my coding streams. That. I could try pasting this into an AI. Well, I'll leave that as an exercise for the viewer. Different browser for streaming, so we don't see. I use Firefox's profiles. It's really useful. That way you can set up different sets of bookmarks and logins and stuff for different streams. It's the means space. Okay. All right. Well, tomorrow. I might do the next problem in Advent of Code then, because we need to do this in time for Christmas. All right. Well, see you in 5-10 minutes for Sonic then. I think I've got 2 hours left on the clock for that. All right. See you. Bye bye.